right, so here is a phase diagram for carbon dioxide, also known as dry ice. We can see we've got some numbers on here, and we can do some analysis of our phase diagram. One thing I want to show you is I want you to notice the solid liquid line. Okay, you see how that's kind of a forward positive slope. Whenever you have a forward positive slope from the solid to liquid line, it's going to tell you that the solid phase is more dense than liquid phase. Okay, because of that positive slope. If you recall, and I'm going to kind of scroll back here, if you look at our liquid phase, I want you to notice that that line is more kind of a negative sloping. It's either almost straight up or it's kind of got a negative kind of tilt to it. That tells me that my liquid phase is more dense. Okay, so that it is more dense. This is the only substance that its liquid phase is more dense than its solid phase, so there aren't too many that'll have that kind of negative sloping liquid solid line. Most of them will look very similar to the carbon dioxide dry ice line. All right, I just wanted to kind of point that out to you because you might see that pop up in a question here or there. All right, so let's read this. So first off, if we want to locate the critical point is going to occur. So critical point is going to occur at a 72.9 ATM.
Mr. Poston, please go to Ms. Cox's room. Mr. Poston, please go.
And a temperature of 31.1 degrees Celsius. All right, so what that tells me is that the lowest pressure that the liquid can exist is at 72.9 ATM. Anything after that, no matter what I do to the temperature, it will be a vapor. All right, so that's the critical point. We can go ahead and locate the triple point, so where all three phases are in equilibrium. That is going to occur, so our triple point occurs at a pressure of 5.11 ATM and a temperature of negative 56.6 degrees Celsius. So if we wanted all three phases to exist in equilibrium, that is the conditions that will be met. So remember, along the line, these are the actual phase changes when both of the phases are present. So this line right here is our sublimation and deposition. This here is our vaporization and condensation, and this is our melting and our freezing. Any of the points that are located along here, that is going to be what phase it is in at that condition.